Okay, this is on section 5.3 on the definite integral. We've already talked about this a little bit. It's definite if it's got an a and a b value, because we'll do both definite and indefinite. Okay, right now we're doing the definite integrals. So this is definite integrals and antiderivatives. And we're going to do these by hand. We will do them algebraically with the paper and pencil, and then you should also be able to check them on the calculator. So we're going to do them both. Before we get to the examples, the author goes through a little bit of the notes. If you're given the derivative, because we're actually, ever since the last section of chapter 4, we're working our way backwards. Okay? If you're given the derivative of a function, we can find the function itself. And then we can find the area underneath the curve. Okay, given the derivative of a function, we can find the function itself, and then we can find the area under a curve. And the process of finding an original function process of finding an original function given its derivative is called integration. We've spent the majority of this year doing differentiation, but this is called integration. I got to spell it right. Integration. Okay. And it is the inverse of differentiation. And I know you've heard me say it before, but it's like you learn how to add and then you learn how to subtract. You learn how to differentiate and then you learn how to integrate. You learn how to multiply, then you learn how to divide. Okay? So it is the inverse. They are inverses of each other. Okay? We've already talked a little bit about the formal notation, but I want it in your notes. The formal notation for the area under a curve from x equals a, and remember x equals a is always going to be the vertical line on the left, to b, and b is always going to be the vertical line on the right. Okay, is, okay, and it's a is, and you use the elongated, looks kind of like an elongated s, that's the integration symbol. It's the integral, and use the lowercase f of x with respect to x from a to b. And as long as there's an a and a b value here, that's a definite integral. You know the two limits on the left and the right. Okay? And when you take the antiderivative of your f of x, you will get an uppercase f of, now, here's the difference. Last week we were doing the general antiderivatives where we had f of x plus c. But now we're actually going to be able to find it because we have our two values there. and it's always, you always substitute in the top one first. So make sure this is an uppercase F of B, and then you subtract uppercase F of A. Okay? And the way you read this notation, okay, it's the definite integral of f of x with respect to x from x equals a to b, or if you just say from a to b, that's all right. Okay. And this part right here is the antiderivative. You actually write it out twice, and then sub in the top number, you sub in the b first, and then you sub in the a. Okay. And that will give you the area underneath the curve. Okay. Okay, now I want to go through some examples. We're going to do, like I said, I'm going to have you do them algebraically, and then I'm going to check, you can check it on the calculator using the FNINT and a second function calculator. So let's go through this. It's the definite integral of x to the fourth with respect to x, and we're going to go from 0 to 2. If I change the letter, a lot of calc books will go, because they're doing things in terms of time, if it was like a polynomial with a t in here, and then it would say dt with respect to t, because that would be the variable. So if they switch that to a different letter, don't let that mess you up. Okay, so you still find the antiderivative. And if you go back, I know we've had a couple days off, you go back and say, okay, this is a polynomial, so you add 1 to that exponent, you divide by the new exponent. Okay? And that's actually our f of x uppercase, but we need to write it out twice. It looks like when you first write this out that every answer is going to be 0, because you write it out twice. Okay? But you write it out just to be able to substitute into it. So now you sub in the top number first. So we sub in the b, f of b. So it's 2 to the 5th over 5 minus, and then you sub in the 0, and that's 0 to the 5th over 5. So 2 to the 5th would be 32. Don't get this far and make a mistake on the arithmetic. You know, 2 to the 5th, 2 times 2, yeah, you got to multiply that all out. Or check it on your calculator. And then 0 to the 5th would just be 0, divided by 5 would be 0. So our final answer is 32 fifths. Okay? Everybody okay with that one? Okay, let's look at another one. Okay? On the second example, say I have the definite integral of 6 with respect to x from 4 to 10. And I'm going to come back and do these on the calculator in a minute. I want to do the arithmetic algebra first. Okay, now if there's no x there, it's actually 6x to what power? Yeah, it's actually like 6x to the 0. So if I add 1 to the exponent, it would be 6x to the first, and then divide by 1, so it's just like 6x. So it's 6x minus 6x. And I don't care if you go across or if you go down. Doesn't matter to me. Okay? So you sub in the top number. Now, I've said that a couple of times. You might want to make a note outside. You always sub in the top number first, the b. So you're going to sub in the 6 times 10 minus, and then 6 times 4. So we'd have 60. You still do the order of operations, 60 minus 24, and you should end up with 36. And that's the area underneath that curve. Okay? Okay, look at number 3. So I have the definite integral of x squared plus 1, that quantity, with respect to x from 1 to 2. Now, depending on which way you like to work it best, some people will split this up into two integrals. Some just work one. If I work one, I would say, okay, add 1 to this exponent would be x to the third, divide by the new exponent, okay? And now this is like x to the 1, x to the 0. So if I add 1 to the exponent, it would be x to the first divided by 1. You agree with that? Okay, now it's like that quantity minus, that's my f of b, okay? And then this would be my f of a. Whoops, I wrote that one. That was over 1. Sorry, that was my fault. Minus x. You agree with that? Do you notice too on these there's no plus c? Because this is a definite interval. Okay. Now you sub in the top number first. So 2, everywhere in this first set of parentheses you're going to substitute in a 2. So 2 to the third over 3 plus 2 minus, and then on the bottom one you're going to substitute in 1. So 1 to the third over 3 minus, oh wait a minute, sorry, this is my fault too. This is plus. What's controlling that to be a plus sign? This. Yeah. Yep. So that ought to be plus. It's minus in between. It's f of b minus f of a. But this is controlled because of this sign. That's my fault. And that should be 1. Okay, so now do the arithmetic. So 2 to the third would be 8 thirds plus 2. And this would be minus 1/3. If you distribute that negative sign, minus 1. So I get 8 thirds minus 1/3 would be 7 thirds plus 1. I get 10 thirds. You agree with that? And that's the area underneath the curve. 10 thirds. Okay? I don't care how you simplify that. You just need to get the right answer when you simplify all the fractions. Okay? On that same problem, I'm going to work it another way because down the road you may decide splitting it up is better. Okay? So if we do the same thing, another method. Start with the same problem. Definite integral of x to the second plus 1 with respect to x from 1 to 2. Okay. If I split that up, it would look like this. The definite integral of x squared with respect to x from 1 to 2. Okay. And what's controlling it in between is this sign, plus the definite integral of 1 with respect to x from 1 to 2. Okay. Everybody see what I'm doing, the difference between? And then I would still do antiderivative of x squared. So antiderivative of x squared would be add 1 to the exponent, be x to the third, divide by the new exponent, divide by 3, and then I need to write it out twice. And when you write it out, this one is like your f of, this is like your f of b minus, f of b minus your f of a. Okay, and the plus sign here is coming from this. So it's a plus sign in between. And this is like 1x to the 0 power. So if I add 1, it'd be x to the first over 1. Okay, and then that'd be the same. Okay. And now you still do the top number first. So 2 cubed over 3 minus 1 cubed over 3. And then plus, this would be 2 minus 1. So we'd still end up with 8 thirds minus 1/3 plus 1. So that's going to be 7 thirds. 7 thirds plus 1, it'd be 3 thirds. And I still end up with 10 thirds. Okay? Just curious, how many of you like first method better? Would rather keep it together? Okay. And for the most part, that's how you will do it. But know that it's available, that if you need to separate them, you can. Okay? So kind of your choice. Let's do one more algebraically, and then we're going to go back. Let's say I give you the definite integral of 2x plus 5 with respect to x from 0 to 2. Okay, let's check. If you split this up, this would be add 1 to the exponent, divide by the new exponent. This would be 5x to the 0, so it'd be like 5x to the first and divide by the new exponent. And then write that out twice. So you could reduce that to x squared plus 5x, right? You agree with that? So these will reduce. So then sub in the 2 first, so 2 squared plus 5 times 2. And then those would both drop out. Right. So you should end up with 14 for your final answer. Okay? Everybody okay with that? Good? Okay. Now, let's check all of these. You can check them 2 ways. Okay? You can use the FNINT, the function integral. In the book, the author uses in the book, because this book was written for all calculators, not just Texas Instruments. So you may see NINT for the function integral. But if you go back, let's look back at go back to number 1 as an example. If we did this, the FNINT, okay, you'd put in the x to the 4th. You got to use that little caret symbol. And it's, remember the math, 9, okay, and then use the x to the 4th, and then the comma, and you always have to put in your variable. We're using an x, and then you have to tell it from 0, you want to find the area from 0 to 2. Okay, so, and we're doing this in the immediate mode. Okay. Okay. And you end up with 6.4. Agree with that? That should agree with that fraction. Okay. If we did this one, number 2, we'd do the FNINT. And you're just going to do 6, comma x, comma 4 to 10. Sorry, 4 to 10. Check it. So it's math 9, and then just put in 6, and then comma x, comma 4, comma 10. Okay, and it works to give you 36. Let's do a polynomial one. FNINT and x squared plus 1. Okay. And from 1 to 2. So it would be math 9. And then x squared plus 1, comma, and the comma, remember, is right above the 7 on a key by itself. And then x, comma, 1, comma 2. And that should check with the 10/3. What's that? Yep. Well, that's coming up. Yours is a little bit the same as this next method. Okay, now, and I don't know if yours, does yours actually show the graph? The picture? Okay, and it may the way I'm doing it. Okay, so the second way. Okay, the second way is to go back. Let's go back to the first one. Under second function, calculate. Okay, with this one we actually need to put in the equation. So go back to y sub 1. In y sub 1, because I want to see the picture. It says the area underneath the curve, so what's the curve look like? So in y sub 1, we're going to put in x to the 4th. Okay, so you need to put x and then use that caret symbol, x to the 4th. And I would say, go ahead and graph it. Get a graph. Okay, zoom, we can do zoom 6. And we're actually going from 0 to 2. There's a lot of this we don't need. Okay, let's get a better window. My x min, let's go even like -4 to 4. Y min, we don't need that much. Let's go -4. Y max. Yeah, but we want to go. Let's see. And if we went to 2, 2 to the 4th power is 2 to the 4th is 16. So I may even want to change my y max bigger. So let's go 16 here. And I don't care what your scale is. Okay. Now, on this method, once you get a good graph, okay, so we've got a picture. There we go. Go back up. We've got a good picture here of our graph, y equals x to the 4th. Okay, and we want the area under the curve from 0 to 2. So do second function calculate. Oh, looky there. Interval, number 7. Okay. Okay, press enter. The lower limit, you just type it in. We're going from 0. Now this is different than when we subbed in the top number first. Okay, but lower limit is the one on the left. Okay, so 0 and press enter. Okay, it actually marks it on the screen for you. Okay, and then 2 is the upper limit. Just type it in, 2, and press enter. Yeah, and it shades it and gets your answer 6.4. So it actually goes from 0 to 2. But when you set your window, like if I put this 2 back in this equation, okay, then 2 to the 4th, I need that on my window. Okay, so then you're actually finding this area underneath the curve, which is pretty slick. I can tell you the first time I set in a graphing calculator thing, and we did all this, and we talked about the area underneath the curve, but math teachers had never ever seen the area underneath the curve like that. It was amazing. Math teachers were clapping all over the place for that one. Okay, on this one, what's this going to graph? Y equals 6. Yep. So, okay. And on your window, even if you go like 7 for your Y max, okay, get your graph, okay, and then we're going to go from 4 to 10. So do second function calculate, number 7, the definite interval, from 4, press enter, to 10, press enter. Oop, I'm not on the window, am I? Check the window. My X max needs to be at least 10. Graph it again. And that's what I mean. It can give you an error if you don't have your window set right. So do second function calculate, number 7. And we want to go from 4 to 10. Okay, and then it gives you the answer down below. So that's pretty slick. Okay, so you should be able to do the definite interval. Okay, and right now we're just doing the regular like polynomials. You figure the antiderivative, write it out twice. You sub in the top number, then sub in the bottom number and subtract them. You should be able to do it algebraically. You should be able to do it using the FNINT, and then you're doing the second function calculate, and that looks like this. And type in the lower limit, type in the upper limit. But your window, you might make a note on that. You have to set your window. Okay, your window has to be appropriate. And then just type in your lower limit, type in your upper limit. It will shade it for you, which is terrific. Okay? Okay, that should get you started.